All right, so we'll get back to section 1, 2. We left off talking about set notation and interval notation. That's really important for various problems that we'll see here. Let's see, let's try this example. So we're going to graph by plotting points and then state the domain and the range. Okay, so what if we had the function f of x equals negative x squared plus 4x minus 3? Okay, I'll go ahead and draw this curve here. So, and I'll just use some values for x and get some corresponding y values. Y and f of x mean the same thing. Okay, so if x is negative 1 squared is 1. There's the negative in front of that, so negative 1 would be leading off. Minus 4 is negative 5. Minus 3 is negative 8. Okay, so negative 1, negative 8, that point would be on the graph. I didn't scale the graph that far, although that point would be there. Okay, if x is 0, y is negative 3. Okay, so 0, negative 3, that point would be on the graph. If x is 1, 1 squared is 1. There's negative 1 would be leading off, though. Plus 4 is 3. Minus 3 is 0. Okay, so 1, 0 would be on the graph. If x is 2, 2 squared is 4. That'd be a negative 4, the leading off. Plus 8 is 4. Minus 3 is 1. So 2, 1, that point would be on the graph. If x is 3, 3 squared is 9. It'd be a negative 9, though, for us. Plus 12 is 3. Minus 3 is 0. Okay, so 3, 0, that point would be on the graph. And then if x is 4, 4 squared is 16. It'd be a negative 16 leading off, though. Plus 16 is 0. Minus 3 is negative 3. So 4, negative 3 would be on the graph. And after we got these points plotted, we'll go ahead and draw the curve. And what we're looking at is a parabola. We're going to do lots of things with parabolas coming up here. Okay, and when you draw a parabola, you want a nice smooth turn through what's called the vertex of the parabola. The vertex is always the highest or the lowest point on the parabola. So here the point 2, 1, that'd be the vertex. If we want to know the domain and the range of this function, okay, so the domain is asking for all the x values. Like here I was selecting some various x values. What can I let x be in general? Well, x can be anything, right? Because this function is saying, you know, take a number, whatever number that is, square it, and then multiply by negative 1, add 4 times that number, and then subtract 3. I can do that to any number I want, right? And I'll just get another number in return. But the point is that I can do that to any number I want. So the domain would be all real numbers. Now I can also get the result by looking at this graph here. So if I scan the x-axis and look above and below each spot, if I'm on the curve, I'm in the domain. If I'm not on the curve, I'm not in the domain. Well, here it's not going to matter where I'm at. You know, so like if I'm at negative 1 and I look specifically below negative 1, I'll be on the left side of the graph. I'll be at negative 1, negative 8. Okay, and then the range is asking for the y values. So what are all the y values? Well, if I scan the y-axis here, and I look to the left or the right, if I'm on the graph, I'm in the range. If I'm not on the graph, I'm not in the range. Okay, so here it looks like anywhere that would be 1 or less on the y-axis, I'd be on the graph. If I'm bigger than 1, I'm up here, and I don't have any graph up here when I look to the left or the right. Okay, so I'd say the set of all y values such that y is less than or equal to 1. Make sure that you're including 1 there, because the point 2, 1, that's the highest point on the parabola. Okay, and anything less than that is also going to be on the graph there in terms of the y values. Okay, here's another example. So what if we had the function f of x equals the square root of x plus 4? Okay, we'll use a table of numbers to graph that curve. So now the domain is, I know that I can't take the square root of a negative. That's not a real number. We'll talk about that more in another section there. But if x is -4, -4 plus 4 is 0, and the square root of 0 is 0. Okay, so -4 is 0. That would be on the graph. Now, I guess after I choose -4, I'd want anything bigger than -4 to also be on the graph. Okay, so like if I let x be -3, -3 plus 4 is 1, and the square root of 1 is 1. So -3, 1, that point will be on the graph. Now, if I don't have a calculator, also I'd want to choose nice numbers, ones that I can find the square root of off the top of my head. So like if x is 0, 0 plus 4 is 4. The square root of 4 is 2. I don't need a calculator for that. Right? So 0, 2, that point would be on the graph. And now the next nice number that I would select would be 5, because 5 plus 4 is 9, and the square root of 9, again, I don't need a calculator for that. That's 3. 5, 3 would be on the graph. Okay, now, I'm not saying that you can't choose like these other numbers, like I can't choose 3. 3 plus 4 is 7. The square root is 7. No, like what is the square root of 7? The only way to know that is to use a calculator and to approximate that decimal. Okay, so I'm really just using numbers where I don't need a calculator for it. Okay, so the domain is going to be all numbers that are -4 or bigger. If I look above and below the x-axis, if I'm on the graph, I'm in the domain. If I'm not on the graph, I'm not in the domain. Okay, so here I've got a half of a parabola. Now, a complete parabola would fail the vertical line test if it's facing out towards the right. It'd fail the vertical line test. Okay, so that would not be a function. I have a function though. Anywhere that's -4 or bigger is going to put me on the parabola. Now when I draw this curve, make sure that it's curved. I'm not drawing a line. That's another kind of function. Okay. The range would be all the y values. Okay, so if I scan the y-axis, look to the left or the right, anywhere that's 0 or bigger, when I look to the left or the right, I'm going to be on the graph. If I'm less than 0, I'm down here in quadrants 3 or 4, and I don't have any graph in quadrants 3 or 4, right? So I'm going to say the set of all y values such that y is greater than or equal to 0. Now, I could have a graph to get that result. I didn't need a graph, though. I could have very easily gotten the result without a graph. So if I ask you the square root of a number, like what is the square root of 9? What would you say? It's 3, right? You wouldn't say -3. Okay, so you're only going to have non-negative numbers coming out to this function. Okay. All right. Let's get some practice finding the domain of a function. So what if we had the function f of x equals 6x squared minus 2x plus 1? In this function here, we're asked to pick a number. It can be any number. And whatever the number that is, you're going to square it, multiply by 6, subtract 2 times that number, and then add 1. I can do that to any number I want, and I'll just get another number in return. Okay, but the point is that I can do that to any number I want. So the domain would be all real numbers. Okay, and remember, there's a couple of different ways that you can write down the set of all real numbers. Okay, I'm using a capital script R here in this problem. Okay, here's another example. We got f of x equals x plus 1 divided by 5x minus 3. So what is the domain of f? Well, I know I can't divide by 0. Division by 0 is not allowed. So in this problem, I'm going to take a look at the denominator, 5x minus 3, and I'm going to set the denominator equal to 0, and I'll solve. If I add 3 and divide by 5, I get x equals 3/5. Now that's what I don't want. I don't want to use 3/5 because if x is 3/5, I get 0 in the bottom. Again, I know I can't divide by 0, so x can be any number, just not 3/5. Okay, so I'm going to say this is the set of all x such that x is not equal to 3/5. Here's another problem. So what if we have g of x equals 3x divided by x squared minus 4? What is the domain of g? So I got another fraction going on, right? So I need to be looking at the denominator, and I know I can't divide by 0. So I set the denominator equal to 0 just somewhere on the side, and I solve the equation. I get x squared minus 4 equals 0. That's going to factor nicely as x plus 2 times x minus 2. And so then when I set each of these factors equal to 0, x equals negative 2 and x equals positive 2 is what I'm getting. Now that's what I don't want. I don't want x to be 2 or negative 2 because those two numbers create 0 in the denominator. I know I can't divide by 0. So the domain, I'm going to say, is the set of all x such that x is not equal to 2 and x is not equal to negative 2. Okay, here's another one. So what if I change up this last example slightly? And in this next function, I'm going to call it h of x. Say h of x is equal to 3x divided by x squared plus 4. What's the domain of h? Well, again, I need to make sure I'm paying attention to the denominator. I don't care what the numerator is. I know I can't divide by 0. So if is there going to be any x value that's going to return 0 in the denominator? No. So if I square any number, I'll never get a negative, right? So negative 3 squared, that's 9. If I square any number, I never get a negative. If I then add 4, it's still never negative, but it's never going to be 0 also. So there's no value for x that will return 0 in the denominator. The domain of h, therefore, is all real numbers. We can let x be anything. Okay, here's another example. K of x equals 3x divided by x squared plus 2x minus 3. Well, again, I know I can't divide by 0. So if I set the denominator equal to 0 and solve this equation here, this is going to factor nicely for me. So x and x, the first terms, the factors of 3 are 3 and 1, so negative 3, right? So I know that the signs have to alternate either plus minus or minus plus. I'm trying to get a 2x in the middle. So let's say I got x plus 3 times x minus 1. If I FOIL this back, I should get the line right above it. X times x is x squared. Negative x plus 3x is 2x. That looks good. And 3 times negative 1 is negative 3 at the end. That looks good. Okay, so that's factored correctly. If I set each factor equal to 0, I get x equals negative 3 and x equals 1. That's what I don't want. I can use any number, just not either of these two. Okay, because those two numbers will make 0 in the denominator. Okay. How about this one? So what if we have f of x equals the square root of 4 minus 3x? So I know with square roots, I can't take the square root of a negative. The square root of a negative, that's not a real number. So just on the side, I'll set 4 minus 3x to be something greater than or equal to 0, because I don't want that to be a negative. And if I solve this inequality for x, let's add 3x and then divide by 3, x would be less than or equal to 4/3. Okay, so I can let x be any number that is less than or equal to 4/3, and that's okay. Okay, so like I don't want x to be 2. 2 is bigger than 4/3. If x is 2, 4 minus 6 would be negative 2, and the square root of negative 2, that's not a real number. Okay, what we'll talk about imaginary numbers in another section coming up here. So I'll say it's the set of all x such that x is not equal to, or such that x is less than or equal to 4/3. Okay. Here's another one. So what if I have g of x equals the cubed root of 4 minus 3x? I'm just changing up this last example slightly. So with a cubed root, now I can take the cubed root of a negative. That's okay. Right? The cubed root of negative 8 is negative 2, because negative 2 cubed gives me negative 8. If I take negative 2 times negative 2 times negative 2, I get negative 8. The cubed root of negative 27, that's negative 3, because negative 3 cubed, negative 3 times negative 3 times negative 3, is negative 27. Okay, so here, like, it's okay that I get a negative underneath a cubed root. The domain, therefore, would be all real numbers. Okay, so with a square root, I don't want a negative underneath. With a cubed root, I can have any number underneath. That's fine. Okay. Here's another example. So what if I have h of x equals the square root of x squared plus 1? Well, I don't want a negative underneath the radical, underneath the square root sign there. So is x squared plus 1 ever going to be negative? So if I square any number, I never have a negative. If I then add 1, I never have a negative. So x squared plus 1 is never going to be negative. Okay, that's why the domain of h would be all real numbers there. Okay, so there's only two things that we're looking for with domain, right? The first thing is that you can't divide by 0. The second thing is that you don't want a negative underneath the square root sign. So here's another example. What if I have k of x equals the square root of x divided by x minus 4? Well, x can't be 4, right? Because that's going to create 0 in the denominator. Also, x can't be a negative because of the square root up top. I got the square root of x up top there. So I just need to say both of those things. Okay. I got the set of all x such that x is greater than or equal to 0 because of the square root sign. I don't want x to be a negative. So x can be any non-negative number, but x can't be 4. We say because we can't divide by 0. So you can use any non-negative number, just not 4 though. That'd be the domain. Okay, here's another example. Let's look at this one, then we'll be done with this video. F of x equals the absolute value of 2x minus 1. So what's the domain? Well, I know that with absolute value bars, anything coming out of the absolute value bars is never going to be a negative. Do I even care about that though? Do I care about what's coming out of the function? No, I care about what's going into the function. So x can be anything, right? X can be any number, and I'm just taking the positive of that number, okay? But the positive of that number, that's going to give me the range of the function. That's what's coming out of the function. But the point is that x can be any number. Okay, so the domain will be all real numbers there. Okay. All right, so we still got a little bit left in section 1, 2. We'll talk about piecewise functions in the next video there. And so we'll go ahead and stop the video here.